Mrs. Chavez. We're finishing up the last part of Chapter 1. I know we've been going through this rather quickly, but I wanted to get the basics out of the way so we can spend more time on much more interesting subjects like culture and language and things like that. So let's get started with the last section. This is Section 3 of Chapter 1. To describe a country is density. But what does this mean? And is it a really good measure of population or any other characteristic of a place? So assuming that we're talking about population, density can be defined as the average number of people per square mile, or if you're anyplace else, per square kilometer. And this is the problem. It's an average. It assumes that people are evenly spread throughout the area that's being considered. The population density of the United States is about 87 people per square mile, or 34 people per square kilometer. But in the next slide, we're going to look at the nighttime map of the U.S. So let's take a quick look. Now this map of the U.S. at nighttime shows a distribution which can be defined as the actual arrangement or spread of the people within a given area. And if you look at this nighttime map, you're seeing that the U.S. population is not evenly distributed. For example, look at over here in the area of the Rocky Mountains. People are at the base of the Rocky Mountains, but there's very few people living in the Rocky Mountains itself. And then, of course, we have the desert over here, this area here, and not as many people living in the desert areas. And in the Baja here, all right? So when you think about it, the amount of people in the United States is the density. You could say that you could take the amount of people divided by the size of the landmass of the United States, but that's not going to give you a very accurate picture. To measure population density is the arithmetic density, which is the total number of people by any given area as compared to a square unit of the land. So, for instance, the total number of people is divided, by example, by a square mile to determine the average density on that area. Physiological density is located right in the middle of this. It measures the total number of people and divides them between the total amount of land that's farmable within that area. So the amount of land that has to be used is much smaller than for the arithmetic density, but the amount of people is much larger than what it would be if you used it just for agricultural density. Now, agricultural density, this means that people who work on the earth on a specific plot of land and that are used for this. It may still be measured by square miles or kilometers, but it only measures square miles or kilometers that are used for growing crops, farmable land, or another phrase that you're going to often hear is arable land. All three of these are used to get a more accurate understanding of the population density of any given area, but they're going to use them in different ways according to the type. You need to know this. The distribution of features in a space. This is what geography is really about, distribution of features. For instance, on my desk, I have my cell phone and I have my computer, and I have them distributed in a certain way, and there's a reason why. Why are things distributed the way they are? That's what geography tries to get at. Sometimes the distribution of physical and human geographic features are spaced out randomly, and other times they're spaced on purpose, like I have my computer and my cell phone in a certain area where they are avoiding the camera. So geographers are going to study this distribution of geographic features on how and why they're arranged in their unique space on Earth. There are three main properties of distribution, especially across the Earth. One would be density, two would be concentration, and three would be pattern. Now, a pattern is the arrangement of objects on Earth's surface in relation to other objects. A pattern refers to distribution, how they're spaced. A linear pattern is along a straight line, like a street and rivers and railroad tracks. Centralized patterns are objects that circle other objects, like the Islamic city. Their houses and public buildings may circle around the mosque. A random pattern means that there's nothing that is regularly seen. It's just randomly scattered, like it could be your bedroom or my bedroom too, for that matter. things are randomly scattered. A rectilinear or a grid pattern reflects a rectangular system of land. Farmland or early township. If you look at a satellite picture of farmland, you'll see that it's broken up into oftentimes rectangular system of land distribution. That is matching patterns, and we want to know how these matching patterns are called and why they indicate that there are two or more phenomena that could be related or associated with one another. That's the definition. Now, example would be like the distribution of malaria. It matches also the distribution of mosquitoes that carry that disease. But just because two distributions have a similar pattern doesn't mean that one caused the other, okay? For instance, I couldn't find my keys one morning. I remember laying them on the counter, and I noticed when I got up that my husband had emptied the trash, and I immediately felt like the cause of my not having my keys was that I somehow dumped them into the trash. It was not true. They were in the bottom of my purse, by the way. So that's what you have to remember. Keep that in mind also. Another example would be the distribution of bicycle shops in a large city. It might be similar to the distribution of an athletic wear store, but the athletic wear store did not cause the distribution of the bicycle shops. What they reflect is the activity and the distribution of activity of the people who use the bike shop and who use the athletic wear stores. What factors are associated with regional features? Let's take a look at these maps. These maps are deaths from cancer per 100,000 people. The first one, let's take a look up here at this this area here. This is a very high density area of cancer. There are 200,000 or above people in this area that develop cancer and die from it, okay? Not just develop it, but they also die from it. So if you're looking at that, don't look at anything else. Just look at that and see if you can come up with some ideas about why they might be dying in this specific area from cancer. And all I'm going to tell you at the top of my head would be that these are maybe poorer states and they have a higher density of population and maybe not enough hospitals and doctors to deal with cancer. Or there could be other things. There could be a myriad of other things that could cause this. So think about that for just a few minutes. Now take a look at this other map over here on the right, and you can see that in this area that we're looking at, what do we see that's distributed here? What are all these things? This looks like some kind of a node. All these things are coming together, and they're also a higher distribution of cancer in this area, 200,000 or more. The first thing that would come to my mind when I'm looking at this would be that I think that there's probably a cancer hospital there, or several, and that people are coming to this area when they get sick from cancer to get treated, and many of them end up dying there. And I would think that that would be the same thing for the next picture. So what might explain these higher cancer rates in these regions? There could be a lot of reasons, but you can look at the map and you can say, okay, wait a minute. I'm a geographer. I'm going to think about this. What is causing this to happen? Okay. Humans need to interact with their environment, okay? We have to obtain our food, our water, our fuel, medicines, we have building materials, and a lot of other things that we get from our environment. Advances in science and technology has helped us to exploit the environment for our own benefit, but we have also introduced other things like pollution and caused a lot of environmental damage. Probably the biggest environmental damage will come from two things, cars, vehicles, and from farming. The impact of environmental problems on humans is significant, though, affecting all human activities. When I think back to that map and I saw all those roads leading into there, I think, well, another possibility for why there were high cancer rates in that area could be because there's so much pollution from all of these maybe crowded highways. So that dual relationship between humans and the natural world are at the heart of what we study in human geography. About the physical things that are around us, okay? The characteristics of the place in which we live. Like we live in the desert, so the characteristics of a desert are going to be dry, not as much water, a dry season and a rainy season. It also refers to that wider natural world of land and sea and atmosphere. Humans have been interacting with their environment since people first walked the earth. For example, humans have been cutting down forests to clear land to grow crops for centuries, and by doing so, we've altered the environment. The environment also affects us in different ways too. A simple example is the way that we change our clothes in response to cold weather. When it's very cold outside, we put on more clothes. When it's really hot, we take off some clothes. A good climate, accessible clean water, fertile soil, all these things are aspects of the physical environment that enable people to live and thrive. However, harsh environments such as very hot climate, limited water, and infertile land make it difficult for people to survive here without technology. We know this because we live in El Paso, how harsh the land can be. We're also affected by major environmental events too, things like earthquakes, floods, and drought that damage homes and property and agriculture. Now, these can lead to the displacement of people and can cause injury, loss of land, and destruction of people's livelihood. They can also damage water sources and pipelines, causing water contamination and spreading waterborne diseases. Our relationship to the environment changed with industrialization. This began in the 18th century in the United Kingdom and shortly followed by everywhere else in Europe and North America, and then spread across the whole world. Prior to industrialization, the impact of human activity was not very significant because the technologies used were not capable of modifying the environment on a large scale. People at that time lived in agricultural societies using hand tools and simple technologies with limited environmental impact. Industrialization has allowed us for a greater exploitation of resources. For example, we now use powerful chainsaws to cut down trees and industrially produce chemical fertilizers and pesticides for crop production. These changes have rapidly increased the human impact on the environment and the human-environment interaction. Let's talk about landscape analysis and observation. Field observations, photographic interpretations. These provide context for understanding the location of people and places and regions and events. We're very visual people. We like to see pictures. We take pictures when we go on vacation, and that reminds us of places that we've been and things that we've seen. Human environment, environmental relationships, and interconnection between and among places and regions is what we're looking at when we talk about landscape analysis. One organization that is using landscape analysis is the World Health Organization, part of the United Nations. As a matter of fact, we just dropped out of the World Health Organization because of some conflicts around COVID. Now, they're mapping all the time and they're analyzing the topography, that's the shape of the land, doing soil analysis in order to determine how to increase nutritional levels, especially for children. And from their site, it says the landscape analysis focuses on countries with high level of chronic undernutrition. Initially, the 36 high burden countries identified by the Lancet Nutrition series. 90% of the world's stunted children live in those areas. However, more recently, there have been additional countries that have undertaken this in-depth country assessments. Once you gather all that spatial data, you have to be able to interpret it. And geographers are going to rely on skills. The skill of synthesizing and integrating, putting together all of the collected information to understand the place, the area, or the landscape that's being studied. So examples are changes in rural and urban landscapes over time, people moving from the country to the city and vice versa. Who are the people that are coming into an area? What are the migration fields like? Why do people from certain areas in Mexico migrate directly to Chicago, and some people migrate directly to the south part of the United States? What are the cultures of these groups of people? What effects will the changes have on local economy? And what are the causes? Why are people moving? What's the push-pull factors that we're looking at here? Just what it sounds like. Human geographies geographers refer to the built environment, and what they mean are the physical artifacts, the things that humans have created and put on the land. The built environment is anything that's been built by human beings: buildings, roads, signs, fences. So therefore, in human geography, we're going to be looking at the different architectural styles of buildings that vary from place to place because different cultures build in different ways, and they create this unique built environment. So anything that's built by humans is part of the cultural landscape. In human geography, we use what we call the four-level analysis. The four-level analysis is a way to study geographic phenomena. First level is comprehension. You establish the basic information: what, where, when, and scale. The second level is identification. You identify and describe the patterns that you're seeing, and are they connected? The third level would be explanation. You explain how the people in this phenomena might form a pattern. And the key questions there would be, why is something where it is? How did something get where it is? And then after you have that, you move up to the highest level, which is prediction. You explain why a pattern is important and predict what it might lead to. So what if this happened? So if we move this, what would happen? What are the effects? That's what we're talking about when we're using four-level analysis: comprehension, identification, explanation, and prediction.